Let's go ahead and review some 6th grade math concepts together. If you'd like to download a free blank copy of this PDF or the annotated answer key PDF, you can find a link to that in the description box below. Feel free to do any of these problems at your own speed and pause whenever you need to think a little bit more. So why don't you go ahead and grab some paper, something to write with, and let's do some math together. For number 1, the question is which of the following expressions are equivalent or equal to this expression that we're given of 2 plus the quantity of 14 minus 9 squared? Okay, so let's go ahead and see what that's equal to first. So I'm going to go ahead and just say we got to follow the order of operations. So the grouping symbol says to look inside here first. So 14 minus 9, that's going to be 5. So this is really just equal to 2 plus 5 squared. And between addition and the exponent, we should do the exponent first. So 5 squared is 25. So we have 2 plus 25, and that's going to be equal to 27. So that's what this expression is equal to. If we look at a over here, we have 9 squared. 9 squared is equal to 81. So that's not going to be what we're looking for. Let's go ahead and X that out. That's not one of our equivalent expressions here. If we take a look at B, we would have to use the order of operations and look inside the parentheses and use that power first, or 2 to the 4th power. That's 2 times 2 times 2 times 2, which equals 16, right? So that's going to be 7 multiplied by this 64 divided by 16. Now, before we do the multiplication, we should do the division that's inside here. 64 divided by 16, that's equal to 4. So we have 7 times 4, and that's equal to 28. So that's also not equal to what we were looking for 27. So this one's not equivalent either. For part C, we have 3 to the 3rd power, which is 3 times 3 times 3. 3 times 3 is 9. 9 times 3, that equals 27. So this one would be correct for answer choice C. And then for part D, let's go ahead and start with the power first. So 2 to the 5th power, that's equal to 32. So it's going to be 32 minus this 15 divided by 3. Between subtraction and division, let's go ahead and do the division first. So 15 divided by 3 is 5. So we're going to have 32 minus this 5, and 32 minus 5, that's going to be equal to 27. So that does check out and equal the expression we had earlier, which was equal to 27. Here is number 2. For number 2, let's go ahead and evaluate this expression. We just have to follow the order of operations here. Between subtraction, exponents, and multiplication, we should use the exponents first. That's 3 to the 3rd power, or 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we have 56 minus 27 multiplied by 2. Then instead of subtraction, we should go with multiplication first here. So this is going to be 56 minus, and then 27 times 2 is going to be 54. And then if we do 56 minus 54, that's going to be equal to 2. So that's going to be the value of this expression. For number 3, it looks like we have another numerical expression here. So evaluate or SimpLEEfy, however you want to think about it is fine. We got to follow the order of operations again. Let's go ahead and look inside the parentheses. Looks like inside the parentheses we have a power. So let's go ahead and solve that first. So we have 65 divided by the quantity of 14 minus, and then 3 squared is 9. And then we're going to add the product of 7 and 3. Next, let's go ahead and figure out what's inside the parentheses. So 14 minus 9 is 5, so it's 65 divided by 5 plus this 3 multiplied by 7. Now we have division and multiplication. They're equally important. We go left to right. I'm going to do this one over here. 65 divided by 5 is 13. We have 13 plus 3 times 7. Between addition and multiplication, multiplication goes first. So 3 times 7 is 21. So we have 13 plus 21. 13 plus 21, that's going to equal 34. So that's going to be this expression SimpLEEfied. Here's number 4. For number 4, we have to go ahead and translate the following verbal sentence into an algebraic expression. Now, when we have this 7 more than, that means we're going to be adding 7 onto something else. And then it looks like we have the cube of the difference of some number A and some number B. Well, let's see. Difference means, first of all, that we are subtracting, right? And then this word cube means we're raising something to the 3rd power. So that little exponent of 3. So let's see. We have to have 7 more than something. It's the difference of A and B. So I'm going to go ahead and take the expression here of A minus B. Well, that's the difference of A and B. And we have to have the cube of that. So the cube of the difference would mean that you have to subtract, then raise it to the 3rd power. And it's 7 more than that. So we have to add on 7 after that. So this would be this algebraic expression that we translated from just a verbal expression. If we knew the value of a and b, we could evaluate this expression, but we don't, so this is as far as we can go and leave it like that. All right, for number 5, let's go ahead and translate another verbal sentence to an algebraic expression. In this problem here, we have the difference, which we said in the last problem means subtraction, and it's going to be the difference between some number x and then the product. Product means we are multiplying something. I'll put a little x for multiplication. The product of 7 and some number y. Okay, so it's a difference between some number x and the product of 7 and some number y. So difference means subtraction. So let's go ahead and take x, and we're finding the difference between that and what? The product of 7 and y. 7 times y is going to be the product, and you can simplify this and say it's x minus 7y. So this would be that algebraic expression that represents the verbal sentence we were given. All right, here is number 6. For number 6, let's go ahead and evaluate this algebraic expression. In this particular problem, a is going to equal 4 and b is equal to 2. So let's go ahead and substitute those values in. So we have 3a, which means 3 times a. So I'm going to go ahead and replace a with the number 4, because that's what they tell us it is equal to, plus 7 multiplied by b, which is going to be 2. And that b has to be raised to the 3rd power. So we went and took that expression, and now it is a numerical expression, and we have to follow the order of operations. Between multiplication, addition, multiplication, and a power, let's go with the power first. So this is going to be 3 multiplied by 4. Again, you can use parentheses or dot for multiplication, plus 7 times what? Well, 2 to the 3rd power is 2 times 2 times 2, which is going to be 8. Now we have 2 multiplication problems. We just go left to right here. 3 times 4 is 12. If you want to do them both at the same time, be my guest, because you'll do them in order anyway. 7 times 8 is 56, so it's going to be 12 plus 56. And then 12 plus 56 is going to be 68. So this would be the value of this expression if a was 4 and b was 2. Here's number 7. Let's go ahead and evaluate another algebraic expression. This time x is going to be equal to 3 and y is going to equal 8. So let's go ahead and make some substitutions here. We have 6 multiplied by something squared. That x value we're saying is 3, okay? And then we're going to go ahead and add 2 multiplied by x. We just said x was 3, so let's go ahead and put that 3 in over here. And this is all going to be divided by what? Well, we have y. Looks like y we are going to substitute with the number 8 we're given. So this is going to be that 8 and then minus 2, okay? When you're doing these problems, you can just go ahead and do the numerator and denominator separately. So if we take a look at the numerator, we have to do the power first. So 3 squared would be 9. So it's going to be 6 multiplied by 9 plus 2 multiplied by 3. And in the denominator, let's see, we only really have one problem to do, which is 8 minus 2. That parentheses doesn't really matter. We're going to get 6. Okay, on the top here, let's go ahead and just keep simplifying here. 6 times 9, that's going to be 54. Okay, and then after that, we're going to end up multiplying this 2 times 3 next anyway, so I'm just going to go ahead and say that's going to be 6, and then we're going to divide by 6. Okay, so on the top, let's just get one number, so 54 plus 6, that's going to be 60, so we have 60 divided by 6, so this whole thing simplifies nicely, just being equal to 10. That's what happens when x is equal to 3 and y is equal to 8. All right, for number 8, we have a variable expression or algebraic expression, and we're going to go ahead and write it as a verbal sentence. So here are a couple options. One thing we could say is the product of 5 and the difference of some number n and 9. Or something like this, where we say the product of 5 and 9 less than some number n. For number 9, let's go ahead and utilize the distributive property to write an equivalent expression. So keep in mind that when we see an expression like this really means this is 4 multiplied by this 1x plus 5, so there's an invisible 1 as a coefficient for that x. When we distribute, we take what's on the outside and multiply it by both terms on the inside. So if we have 4 of these 1x's, 4 times the coefficient of 1 is going to be 4, so we have 4x. And then we have 4 of these positive 5s. So if that's the case, 4 of these positive 5s is equal to 20. So if you go ahead and distribute, we get this expression of 4x plus 20. Here's number 10. And for number 10, let's go ahead and see, we have to go ahead and use the distributive property to write an equivalent algebraic expression. So one thing we can do here is, technically you could write 1, but this is a little bit silly. 1 is a common factor, so you could write 14x minus 21, but you can always do that. If you want to distribute, you can go ahead and get back to the original expression we have. But when you are using the distributive property, we generally try to find the GCF. The GCF of 14 and 21 happens to be 7. So you typically pull out that GCF on the outside. Now 7 times 2x would get you that 14x, and 7 times a negative 3 would get you that negative 21. So if you want to distribute to check, this would be 14x and this would be negative 21. So this would be an equivalent expression if we use the reverse of the distributive property. This is called factoring. For number 11, let's go ahead and determine which of the following possibilities of 21, 0, 16, 19, and 13, we're trying to see which one of these is the actual correct solution for the given equation. So typically when you're given these, we actually just go ahead and try substitution. If you want to try solving it a different way, that's fine too. But if we go ahead and take this 21 right here and we substitute it in, this would be 2 multiplied by 21. And then we would add 19. And we would see if this is equal to 57, right? We're just trying to see if this is true or not. 2 times 21 is going to be 42. 42 plus 19, the question is does that equal this 57? I don't think so. If we add 42 plus 19, that's going to be 61. And 61 is not equal to 57, so that's not true, right? So we can cross 21 off our list here. If you want to try the 0 next, you go ahead and just take that 2. And you multiply it by the 0. This one looks like it's not very promising at all. So if you want to abort now and just say you don't think this is going to work, that's fine. 2 times 0 is 0. 0 plus 19, is that equal to this 57? We don't know if these are true technically, so let's put question marks. But then we get 19 equals 57. That's not true, right? So we can go ahead and cross that out. So we know the 0 here did not work out either. Next, we can go ahead and try this 16. So if we have 16, it'd be 2 multiplied by this 16, and then adding the 19. We're going to see if that's equal to 57. Again, it's a little tedious to do, but if you don't know how to solve equations using properties of equalities, you're kind of stuck doing this and just seeing which one works, and that's fine. Adding 32 plus 19, that's going to be 51, I believe. Is that equal to 57? Well, we didn't know, we still didn't know, and now we know it's definitely not true. Okay, so that's not the solution either. Next, let's go ahead and try 19. Let's have 2 multiplied by this 19, and then we're going to add 19 and see if that's equal to 57. All right, so 2 times 19, that's equal to 38. 38 plus 19, I guess we have to ask ourselves, is that equal to 57? Well, 38 plus 19, that happens to be 57. So since 57 equals 57, then this 19 must have been the solution. So we can go ahead and conclude here that this is our solution that we were looking for, this 19. And so we can say x equals 19. That would be the value that makes this equation true. That being said, we know 13 is also not the solution. Okay, so there's got to be more efficient ways of solving equations. You could guess and check, obviously, like we just did here, and that's what number 12 is all about. We're going to go ahead and use 2 properties of equality and 2 identity properties to solve the following equation. So I'm just going to go ahead and copy down the equation of 4x minus 15 is equal to 65. When you're solving equations like this, one POE or property of equality is we start by adding or subtracting. In this case, we're going to add because we have a negative 15. Now negative 15 plus 15, that's going to equal 0. Okay, so we use the property of equality, the addition property of equality, and right here we can see that if we add 0, we can actually drop that, and that's using the identity property of addition. Next, we want to go ahead and get a coefficient of 1, so we can divide both sides by 4. That's the division property of equality. 4 divided by 4 is going to be 1, so we have 1x equals, and then 80 divided by 4 equals 20. And then using the identity property of multiplication, we can drop that 1 and say x equals 20. By adding 15 to both sides, we use the addition property of equality. By dropping this plus 0, that's using the identity property of addition. By dividing both sides by 4, that's a division property of equality. And then by dropping this 1 in front of the x, that invisible coefficient, that's the identity property of multiplication. Here's number 13. Let's go ahead and try another one of these equations using those properties of equality and identity properties. Let's go ahead and just start by writing down the equation. 46 is equal to 3/4 multiplied by y, and then plus 7. So just like last time, we should always add or subtract on both sides first. So let's go ahead and use the subtraction property of equality. On the left side, 46 minus 7 is going to be 39. On the right side, we're going to have 3/4 multiplied by y. I'm just putting that dot in there, plus 0, okay, because negative 7 plus 7 is 0. Then we can go ahead and drop that 0 and say 39 is equal to 3/4 times y. We don't have to write the plus 0 using the identity property of addition. And then finally, we want a coefficient of 1 for y, so let's go ahead and divide both sides by 3/4 and divide both sides again by 3/4. On the left side, we have to go ahead and take this 39 and divide it by 3/4. So if we take 39 over 1 and divide that by 3/4, we can go ahead and solve that by multiplying the 39 over 1 by the reciprocal of 3/4, which is 4/3. This 3 and 39 are going to cross cancel to make 1 and 13. So then 13 times 4 is going to be 52 over 1, which is just 52. So on the left side, we're going to have 52. And on the right side, this 3/4 divided by 3/4 is just equal to 1. So it's going to be 1y, or 1 times y. And then using the identity property of multiplication, we can drop that 1 and say y is equal to 52. All right, for number 14, it looks like we have an inequality. We're looking for 3 solutions. That means 3 values of x that make it true. You can totally just make up some numbers and try them to see if they work, or we can go ahead and do it systematically. So 5x minus 3, we're saying, is greater than 42. We can do this systematically by using properties of inequality. So you can add to both sides here, just like we did with the equations. If we do that, this 5x is going to be greater than 45. Again, that plus 3 and minus 3 becomes 0. I'm just not writing that right now. And then we can also divide both sides by 5 using the division property of inequality. We get 1x, or just x, is greater than 9. So any number that's greater than 9 will make this inequality true. So x could equal 10. We could also say that x could equal 15. And we could also say something like x is equal to 20. So these would be 3 solutions, but as long as you chose anything that is greater than 9, you would have been fine. For number 15, they're specifically asking us to use some properties of inequality like we just did. So you didn't have to earlier, but it helps us kind of get the solutions more efficiently. So let's go ahead and get x alone. I'm going to start by using the property of inequality and subtract 12 from both sides. If we do that, then this 47 minus 12 is going to be 35. 35 is going to be greater than this 7x. And then we have a plus 0, so let's go ahead and write plus 0. We can go ahead and drop that plus 0 though and say that 35 is going to be greater than 7x. Next, we can go ahead and divide both sides by 7 using the division property of inequality. 35 divided by 7 is going to be 5, so 5 is greater than 1x because 7 divided by 7 is 1. So 5 is going to be greater than x. Drop that 1 by the identity property of multiplication. So finally, we can just go ahead and write our solution and say that if 5 is greater than x, then x is less than 5. In terms of graphing a solution for this, what we're going to do is just draw a quick number line. We're going to put 5 in the middle here and put 2 numbers bigger, like maybe 6 and 7, 2 numbers smaller, like 4 and 3. And then we're going to go ahead and put an open circle because x can't equal 5. X has to be less than 5, so we're going to go to the left here. These are all the numbers less than 5. All right, here is number 16. For number 16, Benny ate 18 treats on Saturday. If this was 1/5 of all the treats that Benny ate on Sunday, how many treats did Benny eat on Sunday? So it looks like Benny ate 18 treats. We can set up an equation here. 18 treats, this ends up being 1/5 of all of the treats that he had on Sunday. Now again, of in math means multiplication, so this is 1/5 of how many treats he had on Sunday. And if we don't know, we can use the variable x. So it's 1/5 of something is equal to that 18. If we go ahead and solve this equation, we can go ahead and actually divide both sides by 1/5, and we can divide this side by 1/5 as well. On the left side, we have 18 divided by 1/5, so 18 over 1 divided by 1 over 5. That's going to be 18 over 1 times 5 over 1. Can't cross cancel, this is going to be 90 over 1, or just 90. So on the left side, we have 90, that's equal to, and on the right side, 1/5 divided by 1/5 is just 1. So we have 1x or just x. So we can say, well, if x was equal to 90, we can say that Benny had 90 treats on Sunday. For number 17, Kodiak had 42 treats on Monday. If this was 2/3 of the treats that Kodiak had on Wednesday, how many treats did Kodiak have on Wednesday? Well, 42 is equal to what? It's equal to 2/3 of whatever was had on Wednesday. Now let's go ahead and use the variable x to represent what he had on Wednesday. So 2/3 of that is equal to 42. We can go ahead and solve for x if we divide both sides by 2/3 using the division property of equality. On the left side, 42 divided by 2/3. That's going to be 42 over 1 divided by 2 over 3, which is the same thing as 42 over 1 multiplied by 3 over 2. And we can cross cancel this 2 and 42 to make it 1 and 21. Then 21 times 3, that's going to be 63 over 1, or 63. So this 42 divided by 2/3, that's equal to 63. And on the right side, we have this 2/3 divided by 2/3, which is 1, which is 1x, or just x. So then x equals 63. Therefore, we can say that Kodiak had 63 of these treats on Wednesday. For number 18, let's go ahead and simplify this following expression. So let's see what kind of like terms that we have here. They're all terms separated by plus signs. So we have 2h here plus another 4h. That's going to be 6h plus another 1h. Remember, there's an invisible 1 in front of that one. So 6 plus 1 is going to be 7. So we're going to have 7h in total if we add all the h's together. And then if we go ahead and take the constants of an 8 plus 3, that's going to be 11. 11 plus 19 is going to be 30. So we have plus a positive 30 here. Okay, so that would be this algebraic expression simplified. Here's number 19. For 19, let's go ahead and simplify another algebraic expression. However, this time we have some distributive property we have to take care of first, so we can't add it until we multiply first. So we have 3 of these 2f, so 3 times 2f, that's going to be a total of 6f. Then we have 3 multiplied by 1 here, that's going to be 3, so go ahead and add 3. Then we have plus f, that's really 1f. I'm just going to write the coefficient so I don't actually make a mistake by accident. And then we distribute this 8 times this 3f, that's going to be 24f. And then 8 multiplied by this 4, that's going to be 32. Okay, so what kind of like terms do we have here? Well, we have no more distribution, so 6f plus 1f, that's going to be 7f. 7f plus 5f is going to be 12f. 12f plus 24f is going to be 36f in total there. And then let's see, I think everything else is positive, which is nice. We have a positive 3 and a positive 32, so that's going to be a positive 35. This right here would be our most simplified expression. For number 20, looks like Miss Jaeger is going to buy a fancy waffle maker that costs $480. That's the total cost of this thing. I'm going to go ahead and write that down. And then she makes a down payment of $100, so that means she's putting $100 towards it right away. Then she's going to make consistent payments of $20 per month until she pays it off. So that means she's going to pay $20 per month. Let's go ahead and use m, it says, as the variable. It says write an equation that represents the situation where m represents the number of months. So then the question is how many months will it take Miss Jaeger to complete paying off the waffle maker? So 480 is the total cost, 100 is a constant because she already paid that, then she's paying 20 per month here. So if we want to go ahead and solve this, let's go ahead and use some POEs, or properties of equalities we know. We can start by subtracting 100 from both sides here. 480 minus 100 is going to be 380. The 100 minus 100 is 0. I'm not going to go ahead and write that. We have 20m on the right side. Then we can go ahead and divide both sides by 20 here. If we do that, 380 divided by 20 is going to be 19. So 19 is equal to 1m, or just m. So we know that this is going to be 19 months before Miss Jaeger is going to pay off this waffle maker. All right, for 21 here, it says which of the following possible solutions is the correct solution for the given equation. Again, just like before, you can go ahead and substitute them in if you want to, and just try each one of these until you find it. I'm going to go ahead and do a more efficient method, which is using properties of equality. So copying down the problem here, we have 7x minus 14 is equal to this 3x plus 22. To solve for x, what we can do is take away 3x from both sides, so that we don't have x on both sides of the equation. If we do that, then 7x minus 3x is 4x. We have 4x minus 14 is equal to, and this 3x minus 3x cancels out, becomes 0. I'm not going to go ahead and write that, and we get 22 on the right side. Next, let's go ahead and move all the constants to the other side. We can do that by adding 14 to both sides. If we go ahead and add 14 to both sides here, we have 4x, and then this minus 14 and plus 14 will cancel out. And this is going to be equal to 36 on the right side. Finally, we can use the division property of equality and divide both sides by 4. We're going to get 1x, or just x, and that's equal to 9. So if we're looking for which one of these solutions is the true one, looks like this 7, 5, 2, and 12 aren't going to work, but if you were trying them all, this 9 would work. So that's the solution. Here's 22. For 22, we have to find the solution to this equation. So this is just a one-step equation, but we have decimals. We have 36 is equal to 2.4 multiplied by k. To solve for k, we got to do the opposite of multiplication, which is division. Let's divide both sides by 2.4. Okay. Let's go ahead and divide this 36 by 2.4 on the side. That's going to be 36 divided by this 2.4. We are going to go ahead and multiply this 2.4 by 10 to make it 24. And let's go ahead and make this 36 multiplied by 10 to make it 360. So we have 360 divided by 24 here. 24 goes into 336 one time. 1 times 24 is 24. Then 36 minus 24, that's going to be 12, bring down the 0. Then 24 times 5 gets you exactly 120. And so we know the answer is 15 here. So 36 divided by 2.4 is equal to 15. And on the right side, 2.4 divided by 2.4 is just 1, or 1k. So k is going to equal 15. That would be the solution to this equation. For number 23, Benny bought 7 of the same dog toys. So we can say if he bought 7 of the same thing, that's going to be 7 times whatever the price of one of them is. And that's going to be equal to this $32.48. Okay, so that would be an equation to represent this. Now, what if we want to find the cost of one of them? Well, let's take the price and divide it by 7. 7 divided by 7 on the left side is going to be 1. So we have 1x. And on the right side, let's go ahead and take this 32.48 and then divide it by 7. A decimal comes straight up. 7 goes into 32 4 times. 4 times 7 is 28. If we subtract, that's 4. Bring down this 4. 7 into 44 6 times. 6 times 7 is 42. The remainder is 2. Bring down this 8 here. 7 into 28 goes exactly 4 times. 4 times 7 is 28. Remainder is 0. So we're going to get 464. So we know the cost of one of these dog toys is going to be $4.64 each. For number 24, if x represents the amount of pieces of candy you're allowed to eat, write and graph an inequality that represents the amount of candy you're allowed to eat if you must eat no more than 15 pieces of candy. Okay, so you can't eat more than 15 pieces of candy, but you can have 15, so it's x is less than or equal to 15. Now, if you're going to go ahead and graph this, go ahead and draw a straight line here, and then we go ahead and put 15 right in the middle, and then we can put something bigger like 16 and 17. You can jump by other numbers if you want, and put numbers smaller like 14 and 13. And let's see here, you can have 15, so it's no more than 15, so 15 is allowed. Make sure you fill in the circle. And we are allowed to have more or less. Well, it's less than because it's no more than 15, so we're going to draw the arrow towards smaller numbers here. For 25, let's just go ahead and evaluate this division problem. So we have 8/15, and we're going to cut it into 6/9 pieces. Remember, when you are dividing, you can actually solve this a little bit maybe easier by taking that first fraction and multiplying by the reciprocal of the second fraction, which is 9/6. Then we can go ahead and try cross-canceling. So any common factors on top and bottom, so like 8 and 6, you can divide them both by 2, and we get 4 and 3. And then maybe this 15 and 9, you can divide these both by 3. 15 divided by 3 is 5. 9 divided by 3 is 3. Okay. You can also cross-cancel more if you see these 3's also are common. So top and bottom, you can divide them both by 3. And so at the very end here, you really just have 4 times 1 and 5 times 1. And if you do all this canceling out now, then when you're done multiplying here, that you actually have no more simplifying to do. 4/5 would be the quotient of the original problem we were given. Okay. For 26, we have another division problem, but this time they are mixed numbers. So if we go ahead and take this 4 and 2/5, 4 times 5 is 20 plus 2. That's going to be 22/5. And we're going to go ahead and divide that by the second fraction, 3 and 2/3. 3 times 3 is 9 plus 2 is 11. So that's going to be 11/3. Now, again, we have another division problem, so let's keep this first fraction and multiply by the reciprocal of the second fraction, which is going to be 3/11. Then check to see if you can cross-cancel. This 11 and 22, their GCF is 11, so dividing them both by their GCF, we get 2 and 1. Then if we multiply on top here, 2 times 3, that's going to equal 6. And on bottom, we have 5 times 1, and that's going to equal 5. So you can actually just write your answer as 6/5, or you could also write as a mixed number, write 1 and 1/5, but those are both good solutions here. For number 27, the question is how many portions that are 1/12 of a whole cake can be made with 2/3 of a cake? Now, in total, we have 2/3 of a cake, and we're trying to cut these 1/12 size slices. So we're going to divide that and see how many times 1/12 fits into this, right? That's basically what's happening here. So we're going to see how many slices we can make. So 2/3, and to do this, we can multiply by the reciprocal, which is 12 over 1. We can cross cancel this 3 and 12 to make 1 and 4. And on top, 2 times 4 is 8. On bottom, 1 times 1 is 1. So we can make 8 of these portions that are 1/12 of a whole cake size big. So 8 of these portions. For 28, let's see what we got going on. We have to find the greatest common factor of 63 and 42. So there's many methods for this, but one common one is using the ladder or the cake method, whichever one you want to call it. For 63 and 42, I think a lot of people might come up with 7 as a common factor. 7 times 9 is 63, and 7 times 6 is 42. Then between 9 and 6, they have another common factor of 3. Now at the bottom here, we have 3 and 2. They are relatively prime, they have nothing else in common. And so if we go ahead and multiply the 7 and 3 on the side here, that's going to get us our GCF. So the GCF, or the greatest common factor, is going to be 21. So that's the GCF of 63 and 42. For 29, we have to find the LCM, or least common multiple. So we have 18 and 15. Let's see what they have in common. So you find the GCF first. So looks like 3 is a common factor. That goes in 6 times and 5 times. And I think that is it. So 6 and 5 are relatively prime. So if we go ahead and multiply this 3 by 6 by 5, this is going to get us the LCM. 5 times 6 is going to be 30. 30 times 3 is going to be 90. So the LCM here is going to equal 90. That's the first time 18 and 15 are going to meet. For number 30, we're going to find the LCM one more time. This time we have 8 and 7. Now this is interesting because 8 and 7 actually have nothing in common besides 1, right? Every number has, or every pair of numbers has a common factor of 1, even if they have nothing else in common. We still have an 8 and 7, so if you ever see this, you can actually just multiply 8 and 7 or whatever numbers are, and you're going to get 56. So we can just go ahead and say that the LCM here is equal to 56. So if the original numbers are relatively prime, just multiply them to get their LCM. All right, for number 31, if you earn $18 selling 3 items, how much would you earn selling 11 of the same items? And so it's going to be $18, and that's for 3 of these items. So what if we just want to find the price of one of them? Well, we can find the unit price by dividing these both by 3. So that would be $6 for one of these items. But what if we want to sell 11 of them? Well, we can take this 1 and multiply it by 11. And if we do 6 times 11, that's going to be $66 for 11 of these items. So we're going to say it's going to be $66. For 32, we have 70% of the students in a school like having waffles for breakfast. If 203 students like having waffles, how many students are in the school? So let's see, not everybody likes having the waffles. So the 203 is part of this total students. So 203 over X over the total is equal to the percentage, or 70 over 100. Okay, so 203, not everyone likes waffles, they're part of everybody, so that's on top, and 70 over 100 is 70%. We can go ahead and divide 70 over 100 by 10 and 10, so if we simplify this, this is going to be 203 over X over the total students is equal to 7 over 10. Okay, let's see if we can figure out 7 multiplied by what number is going to be 203. I think that number is going to be multiplied by 29, just because I know 29 times 7, you can see here, is going to be 63. Carry the 6, that's going to be 20. And I knew that just because 30 times 7 should be 210. Right? Because 3 times 7 is 21, add a 0. So I figured if 29 times 7 is just 1 less 7, that would be 203. So that's kind of how I did it in my head, right? Down here then, you should also multiply this by 29. So 10 times 29 is 290, so X would equal 290, right? So there's going to be 290 total students here. And it should be more than 203, right? Because 203 were just the ones that liked waffles. So there should be more students, the 30% more, and that would be 290 total. For 33, there were a total of 60 athletes who participated in a recent track meet. 48 of them broke their personal records. What percent of the athletes broke their personal records? Now 48 broke them out of the 60. So that's going to be that fraction. and we're wondering what is the percentage, so we don't know the x over 100. So anything over 100 is that percent. We don't know what it is, so let's go ahead and write x percent or x over 100. On the left side, let's see, we can divide these both by 12. You can go ahead and do that GCF work on the side if you need to. 40 divided by 12 is going to be 4, and then 60 divided by 12 is 5. So we have 4/5 is equal to x over 100, and then 5 multiplied by 20 is 100. 4 multiplied by 20 would be 80. So x would be 80, and if it's 80 over 100, it would be 80% of the students broke their personal records. Here's 34. For 34, let's go ahead and find the mean absolute deviation of 9, 5, 15, and 3. So to find the mean absolute deviation, we're going to start by finding the mean or the average. So 9 plus 5 plus 15 plus 3. We have to go ahead and add them up and find their sum and divide by 4. So let's see, 9 plus 5 is 14. 14 plus 15 is going to be 29. 29 plus 3 is 32. So we have 32 divided by 4. So we know the average here is 8. So we see the average is 8, but let's see what all the deviations are. So we have 9, 5, 15, and 3. And we want to figure out how far, what all the deviations are from 8. So we're going to go ahead and subtract 8 from all of these. And if we find out all these deviations, some are going to be positive and some are going to be negative. So what we're going to do is go ahead and find out the absolute deviations of these, which is how far they really are. It doesn't matter if they're positive or negative. So 9 minus 8 is 1. The absolute value of 1 is 1. 5 minus 8 is negative 3, but the absolute value of that is positive 3. 15 minus 8 is 7. The absolute value of 7 is 7. 3 minus 8 is negative 5. The absolute value of negative 5 is positive 5. All right, so these are all of our absolute deviations, and we're going to go ahead and take these absolute deviations and add them up, and then divide by how many numbers there are. So we're finding the mean absolute deviation divided by 4. Now 1 plus 3 is 4. 4 plus 7 is going to be 11. 11 plus 5 is 16. So this is going to be a total of 16 over 4, which is equal to 4. So on average, each of these numbers have a deviation of 4, or they're 4 away from the average on average. All right, for 35, let's go ahead and see if we can find the interquartile range, or the IQR, for this data set. In order to do that, we generally start by writing the numbers in order from least to greatest. So the smallest number I'm seeing here, it looks like it is 2. I'm gonna go ahead and put a 2 here. And then it looks like we have another 2, so I'm gonna put another 2 here. I think we have no more 2s. How about any 3s? No 3s. I see a 4 and a 4, so I'm gonna put 2 4s down. And then do we see any 5s? We have 5 and a 5, so there's 2 of them, so 5 and 5. After that, are there any 6s? Looks like there's a 6 over here. 7s, I don't see a 7, but I do see an 8, 8, and an 8, so 3 8s, 8, 8, and 8. Any 9s? Looks like there's a 9 over here up top. No 10, but there is an 11, so I'll put 11 here. And then 12, 13, 14, 15, 16, 17. I see a 17. And let's see, 18, no, 19, yes. Let's put a 19 here. We have a 20, no, 21, yes. Let's go ahead and cross out the 21. And then I think 28 and 48 are the next biggest number. So we don't need a comma after this last one. So let's see how many numbers there are. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17 numbers. If there are 17 numbers, that means that 8 of them are on the lower side. So 1, 2, 3, 4, 5, 6, 7, and 8. That's going to be the lower 8 numbers that we have right over here. And that means that we're also going to have 8 numbers that are above. So 8 and 8 makes 16, and then there's going to be 1 number left. That is going to be the 17th number. So if we are wondering, that 8 in the middle here, this is going to be our median, or the middle number. Now to find the lower quartile, or the quartile number 1, we have to find the middle of the bottom half. So if we go ahead and find the middle, cross off top, bottom. Let's see, that's 3 and 3. It looks like we have 2 middle numbers here. So for the lower quartile, I'm going to call that the lower quartile, or LQ. I'm going to call that is 4.5, because that's halfway between 4 and 5. And if we look at the top half, let's go ahead and cross out maybe 2 on the bottom, 2 on the top, maybe 1 more on bottom, 1 more on top. and we have to go in between this 17 and 19. And so right between 17 and 19, that's going to be 18. Okay, so how do you find the interquartile range, or the IQR? The formula for that is going to be the IQR is equal to that upper quartile minus that lower quartile. And so the upper quartile is 18 and the lower quartile is 4.5. And so subtracting that, we're going to get 13.5. So the middle 50% of the data has a range, or a spread, of 13.5. All right, for 36, we have to find the surface area of a rectangular prism that has a length of 8, a width of 5, and a height of 7. So if we're trying to visualize this, well, the surface area, we're going to have 2 of the length times the width. So we have 2 times length times width. That's going to be 2 of the sides. Plus, we're going to have 2 times the length times the height. And we're also going to have 2 of one last thing, which is going to be the width and the height, right? So there's going to be 2 of each of them. So if we have 2 of the length times the width, length is 8 and the width is 5. So there's going to be 2 of those. Plus there's going to be 2 of the length times the height. The length we said was 8 and the height is 7. And then finally we have 2 of the width times the height. So the width we said was 5 and the height was 7. So 8 times 5 is 40, 40 times 2 is going to be 80. That's going to be the first 2 rectangles there. 8 times 7 is 56, times 2 is going to be 112, okay? And then plus 5 times 7 is 35, times 2 is 70. So these would be all 6 of them together. If we go ahead and add the 80 plus 70, that's 150. 150 plus 112 is going to be 262. So the surface area is going to be 262 square inches. That would be the surface area here. For 37, we need to go ahead and run a total of 4.5 miles to complete a workout. If you run 0.25 miles every 8 minutes, how long will it take to complete the entire workout? So we're assuming there's some resting going on here. If we want to know how many times we have to put that 0.25, how many times it's going to fit inside that 4.5, we can take that 4.5 and divide it by 0.25, okay? If we do that, we can go ahead and take the divisor and multiply it by 100. And if we do that, we should do that to the dividend as well. So this becomes 450 divided by 25, and that's a little bit easier to divide. So if we do 450 divided by 25, it's going to go in 1 time to 45, that's 25, with a remainder of 20, and bring down the 0 here. So 25 into 200, that's going to be 8. 8 times 25 is 200, remainder of 0. So this is going to happen 18 times. So 18 multiplied by that 8 minutes for each one of those, that's going to be 64 with a 6. 8 times 1 is 8 plus 6 is 14. So this is going to take 144 minutes, just because it's going to take 8 minutes to complete each of these, because there's going to be some rest going on in between as well. Or maybe not, who knows? Alrighty, for number 38, we have to find, using absolute values, the distance between these 2 ordered pairs. If you look at these 2 ordered pairs, this one is in quadrant 2. This one's going to also be in quadrant 2. Notice how they have matching y values of 3. So if they're both in the same quadrant, we're going to go ahead and take the absolute value of one of these, preferably the one with a larger absolute value, and minus the one that has a smaller absolute value. Okay, so the absolute value of negative 9.4 is 9.4. The absolute value of negative 0.8 is 0.8. Subtracting these, we are going to get 8.6 units. Okay, if you want to visualize this, you can go ahead and plot these points down as well, but since they're in the same quadrant, we are going to subtract their absolute values. All right, for 39, let's go ahead and evaluate this expression when x is equal to 6. I don't recommend just going ahead and substituting it in. I'd rather, I think, go ahead and combine some like terms. So 4x plus 2x is 6x. 6x plus 1 more x is going to get 7x. So we have 7x here plus. And then we have constants of 8 plus 5 is 13. 13 plus 6 is 19. So we have plus 19 here. And we see here that x is 6, so if we've done this correct, we can just go ahead and substitute in that 1 time once we've combined all the terms here. So it's 7 multiplied by 6, and then plus 19. 7 times 6 is 42. 42 plus 19, that's going to be 42, plus 10 is 52, plus 9, that's going to be 61. Here is number 40. For number 40, it says evaluate the following expression when y is equal to 6. Again, I wouldn't plug it in the beginning right now. I would actually go ahead and simplify this the best we can. So let's go ahead and use the distributive property. 3 times 2y is going to be 6y. 3 times 5 is going to be 15 plus 4y plus, let's go ahead and distribute 2 times 6y and 2 times 11. 2 times 6y is going to be 12y and 2 times 11 is 22. 6y plus 4y is going to be 10y. 10y plus 12y is going to be a total of 22y. Let's go ahead and add up what else we have here. So we have constants of 15 plus 22. So that's going to be a total of 37. Okay. Now remember, y is equal to 6. So let's go ahead and solve it when y is 6. So it's 22 multiplied by 6 here. And then we're going to go ahead and add 37 afterwards. Now 22 times 6 is going to be 132. 132 plus 37. And 132 plus 37 is going to be 169. For number 41, let's go ahead and find the area of a triangle on the coordinate plane with the given vertices here. So let's see what we have. For this one, I think it might be a little bit more helpful to see a visual. So I'm just going to make a very rough sketch here. So 5, 3, that's going to be 5 to the right and 3 up, maybe something like this. And then B is going to be negative 3, 3. So maybe something in quadrant 2 like this. And then C, we have negative 4 and then negative 6. So somewhere down here like this. We can see our triangle here roughly is going to be this A to B would be our base. And then we can see it's an obtuse triangle. So it's kind of larger than 90-degree angle there. Between A and B, this would be our base. So for A and B, they have matching 3s. So we can see how far apart is this 5 and negative 3. So I think the base here would be 8 because 3 plus 5 is 8. And then how tall is this? Well, the highest y value we have for A and B here, it looks like A and B have a y value of 3. But what's the lowest y value? That's the y value for C. That's going to be at negative 6. So it looks like the highest point is 3 and the lowest point is 6, or negative 6 rather. So how far apart are 3 and negative 6? Well, they're 9 away from each other. So the height here is going to be 9 units. All right, so we know for areas of triangle, hopefully, we have that formula of base times height divided by 2. The base here is 8, the height is 9, and we're dividing by 2. 8 divided by 2 is going to be 4, so it's going to be 4 times 9. That's going to be 36 units squared. For 42, the ratio of ducks to chickens is going to be 5 to 3. All right, so if we write our ratio of ducks to chickens here, that's going to be saying that's going to be 5 to 3, okay? If we want to say what the total is for 5 and 3, the total is going to be 8, right? Because 8 is equal to 5 plus 3. And let's see, we're trying to get another ratio here, but now the total is going to be 96 instead. So how does 8 become 96? So that looks like there's 12 times more total animals here. So we should take everything and multiply it by 12. So 5 times 12, that's going to be 60. 3 times 12, that's going to be 36. So it looks like if the question is how many ducks are there going to be, there would be 60 of these ducks. And then for the chickens, there are going to be 36 chickens. So that's keeping the same ratio. And now there are 96 of these in total now. For number 43, we're going to go ahead and order these rational numbers, just fractions, decimals, anything that can be written as a ratio of two integers from least to greatest. The smallest one here is, I believe, going to be this negative 5.4. Okay, it has the greatest absolute value. Then I think we have negative 5 next. Okay, and then we have to look for more negative numbers. We have negative 4.3, and we have this negative 4 1/4. Now, negative 4.3 is negative 4.30. Negative 4 1/4 is negative 4.25. So the one that is more negative would be negative 4.30. So I'm going to write negative 4.3. After that, we have negative 4 1/4. That would be a little bigger. And then we have the 0, that's bigger than that. And then 3 is the only positive number, so it should be last. That's the biggest number here. All right, for 44, it looks like Mr. Lee's bank account was originally at $17 after withdrawing $85. Now, withdrawal means you take out $85. The account was now at negative $68. The question is which expression represents the amount the account changed by due to the withdrawal? Okay, so the change here that we're talking about is the withdrawing of $85. So that was being taken out. So A doesn't talk about anything about negative, so we do need a negative number here. D and E don't even mention the correct value that it's changing by. Now, if we're trying to figure out which one represents the amount that it changed by, we are going to actually go ahead and use the one that has the absolute value here, right? So it did go down by 85, which is negative 85, but we're just talking about how much it changed by. We wouldn't actually say it changed by negative 85. We would actually say that it changed by 85. And hopefully that makes sense because the absolute value of negative 85 is this 85. So it did go down, so that negative needs to be there. But when we talk about just the change, we consider that the absolute value version of it. So that's the most precise way of thinking about this. For number 45, a 4.5 quart container is used to store pizza dough. If 3 cups of pizza dough are added to the container each hour, exactly how many hours will it take the 4.5 quart container to be full? So assuming that it's empty at the beginning, we're going to start adding some in. We're going to see how many hours this will take. Okay, so let's figure out and convert these to the same units first. So 4.5 quarts. How many cups are in a quart? Well, there are 2 cups in a pint, and then there's 2 pints that are going to go into a quart. So we want to convert this all to just cups right now. We can go ahead and multiply this and say that for 1 quart, we actually have 4 of these cups. Okay, so 2 cups in a pint, 2 pints in a quart. Looks like we can cross cancel the quart and the quart here. And then on top, 4.5 times 4, that's going to be 18. So that's going to be 18 cups. So that's how big this container is. Okay. And so we're going to keep putting in 3 cups every hour. 3 cups, 3 cups, 3 cups. We want to see how many times it fits in. So that's going to be 18 divided by that 3. And that's going to be 6. So after 6 hours go by, after 6 hours go by, then that 4.5 quart container, which is also known as 18 cups, is going to be completely full because if you keep adding 3 cups at a time, 6 times, that's 18 hours. Because if we add 3 cups at a time, every hour, it would take 6 of those hours to make that 18 total cups or 4.5 quarts. Here's 46. For 46, if a student can run 80 yards per minute, what is the student's rate in feet per hour? Okay, so we have 80 of these yards. That is in 1 minute, and MIN. We want to get the rate in feet per hour, so let's go ahead and use some conversion factors here. So let's see, we want to go to feet, so 1 yard is equal to 3 feet. We can go ahead and cross cancel the yards and the yards here, so we just have feet per minute right now. And we also want to get this to be hours, so let's see. We want the minutes to cancel out, so there are 60 minutes, and that's in 1 hour. Okay, so the minutes and minutes will cancel out as well here. And so we're going to go ahead and multiply this all together. Now 80 times 3 is just going to be 240. 240 times 60, we can go ahead and say 240 multiplied by 60. We can just do actually 24 times 6 and then put 2 zeros on after. So that's going to be 24, carry the 2. 2 times 6 is 12, plus 2 is 14, so 144. And then we have to add 2 zeros on. So this is going to be 144, and then put 2 zeros on. So it's 14,400 feet, because that's the only units we have left on top here. And then we have per hour. So that's how many feet per hour that this student can run. For 47, we have a coordinate plane, and point A is going to be located at 6, -2. So let's go ahead and just sketch this real quick. 6, -2 is going to be somewhere in quadrant 4. Maybe that's over here. This point is going to be reflected across the x-axis. So here's the x-axis. If we reflect it, then it's going to be on the other side of the x-axis. So here's A prime, or the reflection. After that, it says it's going to be reflected across the y-axis. And so we reflect it across the y-axis. That's this vertical line here. That means we're going to flip it to the other side of the y-axis. And so that's going to be right over here. We're going to call that A double prime, or that reflection. Okay, so the original point here we said was going to be 6, -2. if we reflected it up, it's going to be 6 comma positive 2. And if we reflected it to the left side here, this is going to be negative 6 comma positive 2, and that's in quadrant 2. So for the final location, we're going to say a double prime is going to be at negative 6 comma 2, or you can just write those coordinates down for the final location. For number 48, the linear equation y equals 4x plus 7 represents the relationship between x, which represents the number of minutes that go by, and y, which represents the total number of chocolates eaten. The question is what if 8 minutes go by, how many chocolates are eaten? So we have our equation, and we know x represents the number of minutes, so let's swap out x for the number 8 and see how many chocolates are eaten. So 4 times 8 is going to be 32. 32 plus 7 is going to be 39. So when x is 8, y would be 39. So we know that 39 of these chocolates are going to be eaten. Then in the second scenario, what if 0 minutes go by? So we have 4 multiplied by 0. So it's 4 times 0 and then add 7. And then so 4 times 0 is 0 plus 7. So if x was 0, then y would be 7. That means 7 in total are eaten. And hopefully that makes sense because 7 were already eaten. And if no time goes by, there's still only 7 that are eaten. All right, for 49, let's go ahead and consider this linear equation y is equal to 30 minus 4x. What value of x results in the value of y being 0? So let's go ahead and just take this y and make it 0. So we're going to say 0 is equal to 30 minus 4x. So let's see what value of x would make this true. Well, we can actually go ahead and take away 30 from both sides. If we do that, 0 minus 30 would be negative 30. And on the right side, we have negative 4x left. And we can divide both sides by negative 4. And we can see here that x is going to equal 30 divided by 4, it goes in, let's see, 7 times 4 is 28 with 2 left over. So it's 7.5 or 7.5. And so if y was 0, that means x would have to be 7.5 for that to be true. For part B, it says what value of y results in the value of x equaling 0. So this time, x has to be 0. So let's see what y would have to be for that to be true. Y would be equal to 30 minus 4 multiplied by 0. Okay, so y would be equal to what? 4 times 0 is 0, so 30 minus 0 is still 30. So y would have to equal 30 in order for x to be 0. Finally, for number 50, we have a parallelogram, and it has an area of 49.77 square meters. Determine the length if the width is 7.9 meters long. So for parallelograms, we have the formula A, the area is equal to length multiplied by width. In this case, we know the area is 49.77 square meters. That's equal to the length, or L, multiplied by the width, or 7.9. If we want to solve this, we can go ahead and divide both sides by 7.9. On the left side, we should do some division. On the right side, we're just going to be left with 1L, or the length. And on the left side, let's go ahead and do the division. So let's go ahead and make both of these 10 times bigger. So we can go ahead and do that division. So this is going to be 497.7. And we're going to see how many times 79 fits inside of there. Okay. Now 7 won't go into 4 or 49, but it will fit into 497. Let's see, I think maybe this 79 times, that's close to 80. 80 times, I think 6 would get you close. That's going to be 54, carry the 5. That's going to be 42 plus 5 is 47. I don't think we can fit in another 79 in there, so I'm going to put a 6 here. That's 474. And we can see the remainder here is going to be 23. Bring down the 7. And let's see, I think this is actually going to be exactly 3. 79 times 3. I know 80 times 3 is 240, and it's a little bit off from there. So let's see, that's a 237. Cool. So that's going to be exactly 237 if we put a 3 up there. So the remainder is 0. So the length here is going to be 6.3. And then so we can say the length is going to be 6.3 meters. Alrighty, so there you have 50 different practice problems dealing with some 6th grade concepts. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And let me know in the comment section down below if you found this video helpful. As always, keep up the great work that you're already doing, and I'll see you in the next one.